So here in this problem, we are given an expression which is a times b plus c minus a over log a. This is equals to b times c plus a minus b over log b equals to c times a plus b minus c over log of c, with some conditions that a, b, and c, these are all positive numbers, and a, b, and c cannot be equals to 1. Now, using these facts, we have to show that these particular expression are equal to each other. Let's begin. So here, what we'll do, we'll begin with whatever is provided to us. So this is given to us. We'll consider, since they are equal to each other, we can say they are equal to one common value. So let's call it 1 over lambda. So this is an assumption. Now we'll begin with our first expression, which is a times b plus c minus a divided by log of a. So this is equals to 1 over lambda. Now we'll cross multiply each other. That will give us log of a equals to lambda times a multiplied to b plus c minus a. Now what we'll do, we will multiply both sides of the equation with b times log of a equals to lambda times ab multiplied to b plus c minus a. Now why did we multiply with b? How did we know that we have to multiply with b? This will become evident in a moment. Now here we have in our expression a raised to the power of b, and when we multiply b with log of a, we can also rewrite it as log of a raised to the power of b by using a property of logarithm. That means if we have a multiplied to log of b, that's equivalent to log of b raised to the power of a. And once we do that, we have an expression for a raised to the power of b. Later on, we can get rid of this logarithm, and this is going to help us prove this particular problem. So that's fine. So this will be equals to lambda times. Now what we'll do, we'll multiply ab to each of the terms within the parentheses. So we have ab squared plus abc minus a squared b. So let's leave it as it is. We'll call it equation number 1. Now let's take the second expression. In our second expression, we have b multiplied to c plus a minus b divided by log of b. So this is also equals to 1 over lambda. We'll cross multiply to get log of b equals to lambda b times c plus a minus b. So can you make a guess what number that we should multiply on both sides? So we need b raised to the power of a. We will multiply with the exponent of b, which is a. So we have a times log of b equals to lambda times ab multiplied to c plus a minus b. That means we can use the property of logarithm to get log of b raised to the power of a, which is equals to lambda. So let's multiply ab with c plus a minus b. This gives us abc plus a squared b minus ab squared. So we'll label this as equation number 2. Now what we'll do, we will add 1 and 2 together. In doing so, let's do that. So we'll add 1 with 2. This gives us log of a raised to the power of b plus log of b raised to the power of a. And we'll add the terms on the right hand side. So here we have lambda. So we can see the lambda is common to both the terms on the right hand side. We'll take it as a common factor. So let's add them. ab squared plus abc minus a squared b. That this will be added to abc plus a squared b minus ab squared. Right. So here ab squared and negative ab squared, a squared b and negative a squared b, these gets cancelled, which leaves us with lambda times 2abc. Now on the left hand side, we can combine these two logarithms to get a single logarithm. Here we can use a property of logarithm. That means if we have log of a and add it to log of b, then the result is the same as log of a times b. So let's use this property, and this is going to give us log of a raised to the power of b times b raised to the power of a. Fine. Now we will get rid of this logarithm. To do that, we'll have to use the definition of logarithm. That means if we have log of a with the base of b and this value is equals to c, then this is equivalent to a equals to b raised to the power of c. So this is the definition of logarithm. Now let's use this definition of logarithm, but to apply the definition, we also need the base of logarithm. So here it's not provided. Whenever the base of the logarithm is not provided, by default it's taken as 10. Now we can use the definition to get a raised to the power of b times b raised to the power of a. So this will be equals to 10 raised to the power of 2 lambda times a, b, c. So this is the value of a raised to the power of b times b raised to the power of a. So let's label this as number 3. Fine. Now what we'll do, we will use equation from this, we'll use this expression and this expression to find out the next value, which is b raised to the power of c times c raised to the power of b. So let's do that. So this is equals to 1 over lambda. We'll start with the first expression. So we have b times c plus a minus b divided by log of b. So that's equals to 1 over lambda. Cross multiplying gives us log of b equals to lambda times b times c plus a minus b. Now let's look at our question. So here we will begin with b raised to the power of c times c raised to the power of b. We'll have to find out this. So we have log of b, so we will multiply both sides with the exponent of b, which is c here. So we have c times log of b equals to lambda times bc multiplied to c plus a minus b. So we'll get log of b raised to the power of c. So that's equals to lambda times bc squared plus abc minus b squared c. This will become equation number 4. And then we'll use c multiplied to a plus b minus c divided by log of c equals to 1 over lambda. So this gives us log of c equals to lambda c times a plus b minus c. We'll multiply both sides with b, so we'll get b log c equals to lambda times bc multiplied to a plus b minus c. Or we can have log of c raised to the power of b equals to lambda times abc plus b squared c minus bc squared. So this will become number 5. We'll add 4 and 5 to get 4 added to 5. This is going to give us log of b raised to the power of c added to log of c raised to the power of b equals to lambda. Common, multiply to bc squared plus abc minus b squared c plus abc plus b squared c minus bc squared. So bc squared, negative bc squared, positive bc squared, negative b squared c, positive b squared c, it gets cancelled, gives us 2 lambda times abc. And these two logarithm will get combined to get log of b raised to the power of c times c raised to the power of b. So our base by default is 10. So b raised to the power of c times c raised to the power of b. This gives us 10 raised to the power of 2 lambda times a, b, c. So let's call it number 6. We have obtained a result which tells us that a raised to the power of b times b raised to the power of a, this is equals to b raised to the power of c times c raised to the power of b, and this is giving us a value equals to 10 raised to the power of 2 lambda times a, b, c. Now finally what we'll do, we'll consider the first and the third expression, that and we'll equate it to 1 over lambda, and when we solve this we will get the result that c raised to the power of a times a raised to the power of c. This value is also going to be equals to 10 raised to the power of 2 lambda times a, b, c. I'm leaving this as an exercise for you. So from, let's call it number 7 and this is number 8. From 7 and 8 we can say that a raised to the power of b times b raised to the power of a will be equals to b raised to the power of c times c raised to the power of b, which is also equals to a raised to the power of c times c raised to the power of a. So this was what we were asked to prove.